Hello, my name is Mustafa Perengürbüz, and this is my Lab 2 for Physics 2212 Lines of Charge. So a quick table of contents of what I'll be doing is I'll be going over the introduction, the conditions and details of the previous lab, Lab 1, because this is a follow-up to that, the questions for the experiment in Lab 1 and what changed for those in Lab 2, coding section, the results of the code, and what if or what does it mean. So for my introduction, the purpose of this new lab is to compare the results in Lab 1 with Lab 2. And in Lab 1, we used a point charge, and now we're going to try to use a linear, like a sort of rod model in GlowScript and compare those two. The fundamental physics principles in this lab consist of mainly the same things we used in Lab 1, Newton's second law, Coulomb's law, and gravitational force, all of which equations are F net equals ma, F equals gm1m2 over d squared, and kq kq2 over r squared r hat. And the preview, our main result, is that the point charge gave a less of a charge than the line charge, and that's because the line charge is more realistic, more like a tape, where like in the point charge, we're not just approximating, it's a tape. So conditions and details of Lab 2 is the exact same as that of Lab 1. The system and surroundings, the top and bottom piece of the tape. The details of the experiment just consist of getting a piece of tape charged by pulling it off a different tape. Our initial conditions are still the same with 20 centimeters of tape length, 1 centimeter of tape width, and the distance of separation between them being 2.54 centimeters. The assumptions we made that were that each tape has the same amount of charge, and we assume that the electrons are, again, evenly distributed amongst the tape. So the questions for experiment, what's the length, the mass? We all did these in lab 1. It's 20 centimeters, 2 times 10 e to the minus 4, etc., etc. The only thing that changed here was that the electric charge, unlike in lab 1, where we just did the point charge model, we're using the rod model in this case. So we need to use kq square root r squared plus l squared over 4 times q to find the electric charge. That's the equation we're using. And so here's my code. I first, on the top right, went along and defined all my constants. Some of them were mostly defined. I had tape length distance. Then I did the definition for the electric field. Didn't change the line charge code because it said not to. I changed the top tape's distance to be my distance away, 0.0254 in meters, of course. And then it ran the bottom code. The possible errors in the lab include that the measurements during the lab weren't really that precise and could have varied some of the data, and the charge of the tape could have decreased during like our handling of the tape while we're trying to touch it and get it into position. So here's our results. That's the picture from my glow script. As you can see, I divided it into 20 pieces, and the green arrows all represent the electric field of each individual piece. The yellow arrow represents the gravitational force, and the white arrow represents the electric force. So what if, or what does it mean? What if the tape was a point charge compared to the line model in Model 2? Well, if the tape was a point charge, then we would have gotten the charge we got in our previous lab, which is 1.187 times 10 to the minus 8. However, in this lab, in lab 2, we got a line charge, which is 2.37 times 10 to the minus 8. And what does it mean? Why are these two different? What makes them different? And which one's closer to the actual true charge? Well, the way we calculate a line charge versus a point charge obviously makes a huge difference. In the line model, we're not just assuming tape is a point. In point charge, we have to assume that, and that's not like close to reality at all. So a line charge or the charge of a rod is much more closer to that of a real life piece of tape. So the line model would be closer to the true charge. And yeah, thank you for listening.